Hey everyone. In this lesson we're going to be talking about a topic that is related to but still different from what we were doing in our last lesson. So before we were talking about the lowest common multiple, or LCM, and in this lesson we're going to start something new, which is called the highest common factor. Highest common factor. Now, just like we had a short form for LCM, we're going to do the same thing for highest common factor, and you will hear me refer to that as HCF. Hopefully you guys can see this more clearly than some of our previous videos. You may notice that there is more light in here now. That's courtesy of my family for sorting that out. I'm still going to see if I can find a better permanent situation for these videos, but hopefully you guys are able to make do with this for now, and hopefully this is an improvement on what we've had in the first 10 lessons or so. So in this video we're going to be talking about highest common factor, and here we're just going to sort of introduce what highest common factor is, and we'll talk maybe a little bit, if there's time, about why it's important, but I do want to get around to an example of actually finding it. So the first thing we're going to have to talk about is what a factor is. So the first thing we're going to do, we're going to approach this by figuring out what a factor is, then we'll talk about common factors, then we'll talk about highest common factors. So we'll start with just this F part, then we'll turn it into CF and then HCF. You might also hear this referred to as greatest common factor, or the other name that I heard when I was in school was greatest common divisor. And so you might see me refer to it as GCD. At times I generally don't refer to it as GCF. If I'm using the F for factor, I'm going to call it HCF for highest common factor, but you might hear GCD slip out now and again from sort of one of the alternative names. But yeah, so we'll start by talking about what a factor is, and then we'll extend that idea to common factors, and then highest common factors, and how to find them. So if we start with talking about what a factor is, so factors are numbers. What am I doing? Factors are numbers that are multiplied together to create a larger number. So this definition, you can write it down if you wish. You don't really need to, like, I'm not going to test you on what is a factor, but you should know what a factor is. So just the way that in a division problem, if I gave you, I don't know, 8 divided by 2 equals 4, just as in a division problem, each of these numbers has a name. This is the dividend, that's the divisor, and that's the quotient. So it's a similar idea for multiplication, except both of these numbers, since in multiplication the order doesn't matter, both of these numbers here are called factors. So both of these right here, the 8 and the 2, would be considered factors of the product that you get, which is, in this case, 16. Alright, so that's one way to think about factors, is that if you multiply two numbers together to get a larger number, then the numbers that you did multiply together are factors of the answer that you got. So this would be your product. So factors are the numbers that you multiply together to get a product. So if I asked you for the factors of 16, it's not only 8 and 2, we'll talk about that a little bit later, but 8 and 2 are both factors of the number 16. Alright, so a second way that you can sort of think about factors is, if you remember when we talked about divisibility rules a few lessons back, factors, if you have a whole number and it can be divided by another whole number, for instance, if you took the number, let's say 24, and you divided it by 6, you're going to get a whole number as your answer, right? 24 divided by 6 is going to give you 4. So this tells us that the number 24 is divisible by 6 because the answer is going to be a whole number. That's what it means for a number to be divisible by another number, is that if you take a whole number and you divide it by another whole number and your answer is still a whole number, then this number that you divided by, your divisor, is a factor of the number that you started with. So that's sort of a second, sort of alternative way to think about it, is that if you take the number that I'm asking you to find factors of and you divide it by something else and you get a whole number, then the number that you divided it by is a factor of the number that you started with. And the nice thing with it, let's take this same example with this 24, is that if I divide 24 by 4, I'm going to get an answer of 6. So once again, I've started with a whole number, I've divided by a whole number, and my answer came out to be a whole number, just as we got a whole number up there. So what that tells me is 4 right here is also a factor of 24, right? So if we think about it in this sort of sense of division, we get that the number that you divide it by and your answer are both factors of the number that you started with, which, if you rewrite it as a multiplication problem, makes a lot of sense. If we don't say this as 24 divided by 6 or 24 divided by 4, then we get 24 equals 6 times 4, right? And then we get back that whole concept of factors being part of a multiplication problem. 24 equals, obviously for multiplication the order doesn't matter, right? So the 6 and the 4 are both factors of 24. So that's sort of two ways you can think about it. One is this multiplication sense of things, where if you multiply two numbers together, then they're both factors of the answer that you get. And the other sense is the division one, that if you divide your number by a whole number and get a whole number as your answer, then both of those are also going to be factors of the number that you started with, of the big number that you started with. So one thing to remember that's important, as long as we're talking about whole numbers and we don't complicate life with fractions and decimals and all of that, factors are always going to be smaller than the number that you're looking for, right? Because if we're only multiplying something by a whole number, if I'm saying 6 times 4, this has to be bigger than both 6 and 4, right? Or at least it's not going to be smaller than either of these. If this was 6 times 1, my answer is not going to be anything smaller than 6, right? It has to be at least the size of your biggest factor in this equation, and it can't be any smaller than that. So that's one thing to remember when you're going through these highest common factor problems, is that your factors are always smaller than the numbers that you're dealing with. So if I ask you to find the factors of 24, none of the factors can be larger than the number 24. And similarly, when it comes time for your test, when we're dealing with lowest common multiples, multiples are, unless you're saying 0, like 4 times 0, in that sense 0 is a multiple of 4, but 0 is a multiple of everything in that sense. But if you're just talking about, if you had 4, and you just start counting by 4s, 4, 8, 12, 16, and so on, for any number, the multiples are always going to be the same size as the number that you started with, or larger, but the factors, so up here is multiples, and down here is factors. The factors of the number 4, that would be the numbers that you can multiply together to get the number 4, are always going to be the size of the number you started with, or smaller. Alright, so that's a very important distinction. Try not to get that backwards when you're going through these questions. If I'm asking you for the factor of a number, or for the factors of a number, your answer has to be smaller than or equal to the number that you started with. And if I'm asking for multiples, then with the exception of 0, which we don't really deal with anyway, then your multiples are always going to be the same size or larger. Okay, so that's an important distinction between factors and multiples. We're not really going to be dealing with lowest common multiple for the next couple of lessons, but then when it comes time for a test review, quiz review, whatever you want to call it, and then your actual quiz, test, quest, whatever, you're going to have to deal with both, so it's important not to get those confused. Now, an important point is that factors of a number, just any number, any whole number that we're dealing with, will always include the number itself and the number 1. Alright, so this is another important thing to note about factors, that if you're dealing with the factors of any number, whether it's, let's say, 6, then you might find other factors as well, but factors of 6 are also going to include the number itself, which is the number 6, and the number 1. So 1 and 6 are factors of 6. And you can replace this 6 with anything, and that 6 with anything. So if you could talk about the number 13, or 17, or 25. 1 and the number that you're dealing with are always going to be factors of that number that you started with. And the reason for that is, if you write it as a multiplication problem, if you say you're dealing with the factors of 24, then you could write a whole bunch of multiplication problems, right? You could write 24 as 8 times 3, or you could write it as 2 times 12, or you could write it as 4 times 6, or you could write it as 1 times itself, right? There's a whole bunch of other ways to write 24, so all of those numbers up there would be factors as well, but this one is always going to show up. It doesn't matter if there are a couple of other ways to write it, a whole bunch of other ways to write it, no other ways to write it, this one will always be there. The number 1 times the number that you're dealing with will give you back that number, right? So that's an important thing to remember when you're dealing with factors, is sometimes people will forget to include the number itself. And sometimes people won't find any common factors, and that means that the largest common factor, or the only common factor, would be the number 1, but they just forgot about it. So the difference between some numbers like, let's say, the number 16 and the number 17 is that 16, you can arrive at the number 16 through the multiplication of two different numbers in more than one way, right? You could do 2 times 8, you could do 4 times 4, you could do 16 times 1, and we're saying that doing 16 times 1 to get to 16 is the same as doing 1 times 16, because for multiplication the order doesn't really matter, so we're treating this case and this case as the same thing. Alright, so we're not really concerning ourselves with the order in which we do this. So we'll say 16 times 1 and 1 times 16 are arriving at 16 in the same way, but you can still do it in a whole bunch of different ways. You can do 16 times 1, you can do 2 times 8, you can do 4 times 4, but for 17, the only way to multiply two numbers together to get to an answer of 17 is to do 1 times 17. There's no other way to arrive at this number other than taking itself and multiplying it by the number 1. So, if you find a number where this is the only way to arrive at it, doing 1 times itself, this number is prime. If it's not a prime number, like 16, you'll find other ways to get to that number, like 2 times 8 or 4 times 4. There are a whole bunch of other ways to arrive at that number. Even if it's not a whole bunch, even if it's only one other way to arrive at that number, as long as there's more than just the number itself times the number 1, then it's not a prime number. But for prime numbers, their only factors are themselves and the number 1. So that's an important thing to remember. So just to sort of reiterate that, I'll just list as a sort of as a few examples, I'll list the factors of a few different numbers, so we sort of ingrain this idea of factors of some numbers and factors of other numbers, composite numbers, prime numbers, all of that stuff in our heads. So if we look at the factors of the number 3, the only numbers that you can multiply together to get an answer of 3 are 1 and 3, right? You can do 1 times 3 and you can do 3 times 1, and that's it. So how many different numbers do we have here? Well, we have the number 1, which shows up twice, and we have the number 3 that shows up twice. We don't care how many times they show up. Some of them will show up once, some of them will show up twice, but how many different numbers do we have here? Just 2, 1 and 3. So 1 and 3 are the factors of the number 3. And because there's no other way to get to 3 other than taking itself and multiplying it by 1, we know that 3 is prime. So if we do the same thing, let's do the same thing with a slightly larger number. If we do something like factors of 7, the only whole numbers that you can multiply together to get to 7, well, you can do 1 times 7, you can do 7 times 1, but there's nothing else you can do. You can't do 2 times a whole number, you have to do 2 times 3.5, which doesn't work. We're not counting decimals and fractions and any of that. So the only numbers that we have are 1 and 7. And again, we don't care if they show up once, twice, thrice, whatever. Doesn't matter to us. So we only have 1 and 7 there. There's no other way to create the number 7 by multiplying 2 whole numbers together. So this tells us, just like with 3, that 7 is prime. Now let's look at one that's not. Let's look at, let's say, the number 12. So if we consider the number 12, then, well, let's see, how many ways are there to get to 12? We'll start by multiplying 1 times 12. So we've got the smallest factor that we can get over here, and the biggest factor that we can get over there. So let's just slightly increase this. Instead of 1, we'll put a 2. And see, does 2 times anything give us 12? And if you go through the math or you think about it, you'll find that 2 times 6 is still going to give you 12. So we've got a slightly smaller, well, I mean, we've got a much smaller factor over there, but we've got a slightly larger factor over here. Let's try going up again. We'll increase this to 3. Does 3 times anything give us 12? Well, sure it does. 3 times 4 is also going to give us 12, right? We got 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. So 1, 12, 2, 6, 3, and 4 are all factors of 12. Now if we go any bigger, if we increase this to 4, we could do that. 4 times 3 is going to give us 12, but now we're just repeating ourselves, right? We already have a 4 and a 3 from our previous line. So we can write this, there's no harm in doing that. If we do it with 5, 5 times what is going to give us 12? Well, that's not going to work. We're not going to get a whole number that we can multiply 5 by to get 12 as our final answer. So 5 doesn't work. Now we go up to 6. 6 times what is going to give us 12? Well, 6 times 2 is going to give us 12. And again, we're repeating ourselves from before. So we've got a 6 there and a 2 there, 6 there and a 2 there, gives us 12. So that's not really presenting us with any new information. Now here's the thing. As soon as well, notice that 6 is exactly half of 12. This works really well for even numbers. It works just as well for odd numbers, but it's maybe a little bit harder to spot with odd numbers. 6 is exactly half of 12, and you can see that by the fact that we're multiplying it by 2 to get to 12. We know that the only factor smaller than 2 that we can have is 1, right? The only thing we can reduce this 2 to is 1 if we still want to get an answer of 12. We're not going to be talking about fractions and decimals, so we're not going to be multiplying anything by a half or a third or a quarter or 1.5 or anything like that. The only thing that we can get as a whole number that's smaller than 2 that still gives us an answer of 12 is multiplying something by 1. So the only thing that we can multiply by 1 to get 12 is 12 itself, right? As long as we're not considering fractions, decimals. Multiplying it by 0 won't help because that won't give us 12. Multiplying it by any negative numbers also won't help because that'll give us negative 12 maybe, or negative something else. So that means that the only number that you can change this to, if you want a smaller factor, is 1, right? And then if you notice, as soon as you hit half the size of the number that you started with, right, you're getting half here because you're multiplying it by 2, then the very next factor that you can get if you increase to the next largest factor, or to the next factor in order, is the number itself. Right, so I don't know if I'm making complete sense yet. Basically, as you go and you increase this first factor, we started with 1, then we went to 2, then we went to 3, then we went to 4, we tried 5, it didn't work, then we went to 6. I already know if I put a 7 here, 7 times 1 is not going to get me 12, right? It's not going to equal 12. So that doesn't help me. 7 times 2 is also not equal to 12, but also 7 times 2 is already bigger than 12, which means that any other number, this 2 or bigger, is going to give me a number that's bigger than 12, right? 7 times 2 is already bigger than 12, so 7 times 3 would be bigger, 7 times 4 would be bigger, and we know 6 times 2 is 12 anyway, right? We already had that information available to us, which means that if I jump to the next number after 6, or after the halfway point of the number that you're dealing with, in this case 12, as soon as I get past the halfway point, which is 6, I know that I can't multiply it by any whole numbers and get the number that I started with, right? If I'm going through the factors of all of these numbers, or of any number, as soon as I hit that halfway mark, I can stop. As soon as I hit that halfway mark, the only thing that I have left to do is that last line of the number itself times 1 equals the number itself. Once you cross that halfway mark, you can't multiply it by any whole number and get the number that you started with. The closest you can get to that number itself is half of that number, because you have to multiply it by the smallest factor you can find that isn't the number 1, which means it has to be the number 2. And if you're multiplying it by 2, then that means you have to be starting with half of the number. If you want to get the number that you started with, and you multiply it by 2 to get there, that means you have to be starting with a number that's half the size, right? So hopefully that's making sense. I'm sort of blabbing on a little bit. I'm going to try and stop that now. But if you look at the factors of 12, we just list off the numbers that we have. We can even get rid of this 4 times 3 down here, because that's a repeat of the line above it. So we can get rid of that as well. And so now we can just list off the factors of 12 that we see in front of us. We have the number 1, we have the number 12, we have the number 2, we have the number 6, we have 3, and we have 4. Right? So these are all different factors of 12, and if you reorder them just in increasing order, you get that the factors of 12 are 1, 2, 3, 4, 6, and 12. And so this is sort of maybe a better way to highlight the point that I was trying to make, is that when you're listing the factors of a number, every factor except for the number itself will be either half the size of the number or smaller. You won't get any factors between half of the number and the number itself. You can try it on your own with larger numbers. Try it with 100. You won't find any factors except for the number 100 that are larger than the halfway point, which is 50. Right? So you can try this on your own if you don't believe me. Otherwise, you can use that, if you do believe me, use that as a trick when you're going through these problems yourself. We could look at one more. How are we doing for time? We're at about 25 minutes now. So maybe, yeah, so we'll look at one more for factors, and then we'll start in the next video, we'll start actually going through common factors and finding the highest common factor. So we're not going to be able to do any of that in this one, just because I don't want the videos to gradually get longer and longer, to be 35 and 40 minutes long, because then you won't be able to finish a single video in one class, even if you started right at the beginning and watched all the way through to the end of class. So I'm going to try and shorten the video length just a little bit so that it doesn't get out of control. So let's look at one more number. Let's look at the factors of the number 16. So how many ways are there to get to 16? Well, we can do 1 times 16, right? We could do 16 times 1, that's no different. We could do 2 times 8, right? We could do 8 times 2. And we could do 4 times 4, right? 4 squared is 16, so we could do 4 times 4. You could flip that, it doesn't change, so we're not going to write it a second time. And that looks like just about it, right? We've got 1. Make it a little bit bigger, we got 2, right? We make that first factor a little bit bigger and see if it still works for us. So 1 is a factor, 2 is a factor, 3 is not. 3 times 5 is going to be 15, and 3 times 6 is going to be 18. So that shows us that 16 doesn't fall anywhere in the list of multiples for 3. So 3 is not going to be a factor of 16, so that doesn't work. 4 works, right? We've got the 4s there. 5 doesn't work. 5 times 3 is 15. 5 times 4 is 20. 16 is nowhere in that list of multiplying 5 by a whole number, so 5 doesn't work. 6 doesn't work, right? 6 times 2 is 12. 6 times 3 is 18. That doesn't work. 7 doesn't work. 7 times 2 is 14. 7 times 3 is 21. 16 just isn't falling into this list at all. 8 we have, right? 8 times 2, right? We have that 8 and we had that 2 from before. So 8 times 2 works. And then, because that's the halfway point to 16, we could try going through with 9 and 10 and 11 and 12 and 13 and 14 and 15. And we're going to find that the only factor of 16 that's bigger than half, that's bigger than 8 in this case, is the number 16 itself. And then we had that 1 from the beginning. Right, so if we go through and we just list all of the factors that we see, well, we've got the number 1, right? So we've got the factors of 16 are going to include 1. Alright, we've got the number 2 over there, so 2 is a factor of 16. I'm trying to go through and find them so we can put them in order, right? So we got 1, so let's actually get rid of it so that the board gets a little bit, less busy. So we got rid of the 1s. And we've also written down the 2s, so we can get rid of that as well. Now the next number in increasing order would be those 4s over there. Remember, we only write it once. We don't care if it's 4 times 4 or 4 times something else. So we can get rid of those 4s. And the only things we have left are 8, which is half of the number that we started with, and the 16 itself, the number itself. So, there we go, there are the factors of the number 16, and again you'll notice that aside from the number 16 itself, every other factor is either half the size or smaller than the number that was our target, which was, in this case, 16. Alright, so let me just rewrite that up here. We've got the factors of 16 are 1, 2, 4, 8, and 16. So there we go. In this one, we've just got on this board right now, we've got the factors of a couple of examples of prime numbers like 3 and 7, and then a couple of examples of factors of composite numbers like 12 and 16, numbers that just aren't prime numbers. So you'll still see that as a rule, the number 1 is a factor of everything, and if you're dealing with the number 3, then 3 is going to be a factor. If you're dealing with 7, 7 is going to be a factor. If you're dealing with 12, 12 is going to be a factor. If you're dealing with 16, 16 is going to be a factor. Right? So the number that you're dealing with is always a factor of itself, and the number 1 is always a factor of itself. The difference is between a prime number and a composite number, or a prime number and a non-prime number, if that's easier for you to think about, is that for non-prime numbers, for composite numbers, you'll have all of these extra ones. You might not have a whole bunch, you might only have 1 or 2 or 3 extra numbers that are also factors of it. But you'll see that for prime numbers, you don't get any extras. You get 1 and you get the number itself. For composite numbers, you get 1, the number itself, and some extra stuff. You get 1, the number itself, and some extra stuff. So those are the differences there. And this is something that can prove to be useful as we go through this as we go through the rest of this unit. I'm trying to encourage you guys to get a little bit more familiar with these prime numbers in case you aren't, just because it makes life a lot easier when you're working on LCM and HCF problems to be familiar with these prime numbers. So that's why so much of the focus in this lesson has been on this. In the next lesson, what I'm going to do, I could have started it now, but I want to show you, just like we did with LCM, we did 3 different methods to find the least common multiple. We're going to do the same thing for highest common factor. There are 3 different methods. One of them is sort of similar to just the counting way that we did for lowest common multiple, and so it's not necessarily the most useful, but still I'm going to show you 3 methods, and then we'll focus on using 2 of those methods more than the third. But I wanted to keep all 3 of those methods in one video, so we're going to do that next lesson. And if you guys have any questions, then you guys know how to get in touch with me. Otherwise, I will see you in the next video. Have a good one.